Hey everybody, welcome to our presentation and actually welcome to the MLOps Candy Shop and Choose Your Flavor. My name is Mariusz Strzelecki. Together with Mateusz Pytel, we are going to show you how we implemented our MLOps platform in GetInData. But before we go to the details, let's get a common understanding on what MLOps is. So for us, MLOps is DevOps-like mindset, but dedicated for data scientists. What does it mean? It's a set of tools, techniques, manifests, and automation that helps data scientists to build a model and deliver them and even deploy them to production on their own or with minimal help of other teams. The main goals of the MLOps is, well, first, shortening time to market for machine learning. We know it already from the companies that we work for, that the time from since the model development to the model deployment to production, it's currently counted in months. We would like this to take weeks or even days. Also automating of boring things. We all hate boring things, and we know that IT is mostly about automating things that are boring. And in creating and deploying a model, there is also a set of steps that can be automated, and MLOps is about automating them all. And also we would like to use the power of containers and cloud. The times when the data scientist works on some server and they develop models and then train models and then they deliver a report as a PDF files, these are history. Right now, the data scientists should feel a freedom of running their models on containers, or for example, if they need some specialized hardware that is not available within the company to go to the cloud. So why the hell Candy Shop then? What is your first thought when you think about Candy Shop? There is a lot of sweets, a lot of colors, a lot of smells, basically a lot of everything. And MLOps is also a lot of everything. We divided all the projects that reside in this area into four different groups. First area is the ML lab. So the place when the development happens, the place when data scientists go to read the data, to understand the data, to build the models, and to create some algorithms and try them. We have a second area that we called ML Gym, and this is the place when training happens. This requires some hardware, maybe some specialized hardware, some pipelines, and this is all the hard work that the computers need to do to deliver the best models possible. Then we have ML Bar, so the serving place, when you go for the predictions from your model, either using some API or by applying the predictions in some batch process. And having a lot of models in production means that we need to check them, we need to validate them, we need to compare them with each other, and this is the place when the ML stock market tools work best, because these are present a view of what is going on in production that you may use for tuning or for making your decisions. Let's go through all of these areas one after another. So first, ML Lab. What are the key aspects that we see here? So first, data catalog. In large companies, and even in small companies, the data reside on different databases in different systems, and we need to provide a data catalog for data analysts and data scientists to let them know where to get the data from, in what format they are, and what they actually present. Then feature store, a special case of data catalog. You may know that the machine learning models, well, they are created by applying some function on features. These are usually some vectors of numbers. And many machine learning models in one company can operate on similar things. So feature store is a central place when data scientists can go to just get the prepared, clean features directly to their models. Variety of ML techniques and libraries. This is also something that we need to support. The new algorithms are emerging daily. Basically, every day you can see some new blog post on some new discovery in this area. And we don't want our data scientists to be limited to only the tools or libraries that we provided for them on our cluster. We want to give them full freedom of selecting any ML technique and any library they need. And also some libraries, well, they work best on specialized hardware, like on graphical card or TPUs or machines with enormous amounts of memory, like 1 TB of RAM. And we don't want, and again, the data scientists to be limited by only the resources that we own. That's why we should support any of this that is available on the market. The second area is ML gym, so the place when training and tuning happens. Here, the key aspect is the pipeline. Pipeline is the way to describe the work that data scientist did in his or her notebook, the steps of, for example, data cleansing, splitting, training, and validating, and to define them in the way that this can be scheduled by some scheduler, for example, at night. So this should be a replicatable way to replicate the work that data scientists did in the notebook to some process that can run in the background. Also, hyperparameter tuning. You may be aware that when you build the machine learning models, you give some input data to this machine learning models, but then this model has some parameters. And hyperparameter tuning is the process of selecting the best possible set of parameters that provide the best efficiency or accuracy for a given model on a given business case. Also, data and code versioning. Code versioning is trivial. You do this in Git and you're happy with this. But data versioning is kind of complex thing. This is crucial when you want to compare two models. For example, the one that you are creating right now and the second that you will create in a month. To do the fair comparison, you should train them on the same data. And this is when the data versioning keeps the important role. Also artifacts, because pipelines, they do not only produce models, but they also create some kind of artifacts like charts, like confusion matrices, and you should be able to provide all of them to data scientists to see how the pipelines performed, for example, during the nightly training. The third area is the ML bar, so the place where serving happens. And here we have models versioning that allows you to roll back to the previous version if you are not happy with the responses of the current model. This is very important when your training pipeline and deploying pipeline is automated, and this is one of the goals. Also, A/B tests, which are pretty popular in the IT world, but multi-arm bandit is some kind of new thing here. You may see this as a way to deploy, release multiple models serving the same business needs, and then observing their performance, and then selecting that maybe traffic to one of these models should be decreased because this is performing badly right now. And this is the place where multi-arm bandit just works. Also, shadow testing and canary testing, because there are cases when you deploy the model and you don't exactly know if it will behave better or not that good on the actual data. And shadow testing, so the way to run two models in parallel, but one model only for reference, or canary testing plays important role in serving machine learning models. And finally, auto-scaling, because you don't want your application to be killed by slowly responding machine learning model. The fourth area, the ML stock market. This is especially useful if you have really multiple models running in production and if you want to get all the KPIs of them in one place. Logging the requests is the important technique if you want to replicate the behavior of the models on production. So you log the request from your users, and then you can see what actually the model predicted and how did it impact your business, for example. Also measuring the data quality, both for training, because you need to be sure that the data that you provide for training are clean and are good quality, and at least the same quality that data scientists seen when he or she prepared the algorithm, but also for prediction, because if you have model trained on some data, but then the data coming into prediction, they are slightly different, it may result in unpredictable behavior. And finally, the most important part is the model's performance. So measuring how actually your models is impacting your business. This is not the trivial thing because rarely you have the information how model impacted the user decision just after applying the predictions. Usually you need to have some time frame to measure it properly. So the 4 areas. In every area works in a bit different environment and has a bit different key aspects. If you know what cloud providers offer, you see that there are some tools implemented by Amazon or Google or Microsoft that aim to support some of these areas, but there is no one solution that fits all. That's why in GetInData, in our platform that we are building for our customers, we decided to go with open source tools that can be deployed on any cloud or even on premise to fulfill these needs. And let me show examples of the services that we install in our platform. So let's get to the ground. We have a data scientist on the left, and this person wants to create some models. And in the MLlab area, we use Amundsen for data discovery. We use Feast as a feature store that we integrate with Amundsen. We use Jupyter, of course, the standard tool for data scientists to work with the data, to explore them interactively. Usually we run them on Kubeflow notebooks because this is very, very flexible solution to run multiple Jupyters at a scale. And we use Kedro to allow data scientists to write the replicable pipelines in the very easy to use way. In the second area, in the ML gym, well, first we need a reliable, robust scheduler. And for this, we use Airflow or Kubeflow pipelines or Prefect. This scheduler needs to run processes in some place. And we use Kubernetes for this because it allows us to use basically any container that is available or a container that we just built for this specific machine learning model. Also, Mlflow plays important role here because when the training happens in the background, you want to see some reports on how different executions went, what were the results, what are the artifacts, and you need the way to log all these things somewhere. Then the third area, so ML bar. Of course, we use Kubernetes as a thing that powers all the models that we are serving. On Kubernetes, we use Seldon API, Seldon Core to be more specific. That is super universal engine that allows us to quickly deploy A/B tests, shadow testing, canary testing, and all these various techniques that are critical in robust ML ops serving. We use Mlflow as a storage for models, for model versioning, which is also a kind of critical part here. And usually we use GitLab CI/CD to automate all this behavior, automate deploying, and provide auditability of what is going on in production. And the last area is the ML stock market. And here we use, well, widely known services like Prometheus and Grafana to provide metrics, to provide nice dashboards. And also we use the power of Seldon that is capable to export very interesting metrics to provide information how the models behave, what is the response time, and so on. Of course, these are only the examples. These are only some services. Depending on the client that we deploy our platform for, we adjust them a bit, but you may get a feeling what kind of technologies we use to power our open source based MLOps platform from this slide. Now, let's do a deep dive into tools that we recently developed in GetInData and we open sourced that fulfill some gaps in the open source world and that you can also use in your MLOps projects to maybe help on your challenges. First, part of MLlab, so feature store user interface based on Feast and Amundsen. And the second part will be covered by Mateusz about integration of Kedro and Kubeflow, a part of ML Gym. So, MLlab and feature store. Well, what feature store is? A feature store is a place to store ML models training data. in structured way, in the way that a lot of models can use them. And predictions. And why predictions? I will tell you in a second. Also, this is a place for collaboration because if the features in feature store are going to be used by different models, by different data scientists across the company, there should be a place to collaborate, to discuss them, to maybe find the best way to store some data. Also, what we found on our project is that feature store presents something that we used to call 360-degree view of the domain of your client, of your customer, or of your subscriber. Why is it so? Well, if there is a place when you store all the data available in different databases in understandable way, all the data that you can get on the user, this is of course the best way to get the feeling of how user behaves, what user does, and this is a central place to actually provide you all the insights that you have on your user, for example. How it usually works, when you have some feature table marked in yellow, and then you have machine learning that uses these features from this feature table, and it creates some predictions. But you can have some other machine learning models that uses the same features as a training data, the same feature table one, but can also utilize the predictions of the model one as an input features. So you can rely on the work did by other models for data scientists to provide even better results for your ML model too. What are the key aspects that we expect from the feature store? First, we want to have fast online serving of the data for API, for use on microservices, for example, and efficient batch serving for training and for doing the predictions in the batch offline way. We need the versioning because this is key if when it comes to data, when it comes to models comparison in a time. If the models are reading the data from feature store, then our data versioning is actually the features versioning in the feature store. We want historical data management because maybe you'd like to split your input data into pre-COVID and after COVID times, and the feature store should support it. We would like to get some built-in data statistics because data analysts, well, they trust the data only if they see the statistics, number of nulls in some column or something like this. So we want to have some data statistics that would be calculated automatically and ensure that the data can be trusted and is stored in the way that data scientists expect for a model. And also we need the API for the code. So you need the API to allow to present you the schema of the features, both for training and for the predictions, but you also need the user interface for analysts to collaborate. And for feature store, we use Feast because Feast covers both the stores, offline store and online store. It has really nice SDK to work on offline data and to do the model training. And also you can do predictions on this offline data, but also together with Kafka and Redis, it provides you online store that can be used for fast model serving. But there is one gap. In Feast, there is no user interface. There was one in the very early version of Feast, but it's not available there anymore. So we decided to use Amundsen as a user interface for Feast. How does it work? So the Feast in our plugin, it's being translated as a virtual database when you can go and the tables, the feature tables are actually the tables of this virtual data frame, and the columns are features and entities in Feast. In this way, we can present all the information, make them searchable. Also using the Feast, using Amundsen interface, analysts can add the descriptions to the features, to the feature tables, and so on. We can also present all the metadata available by Feast API. If you'd like to use it, if you'd like to try our approach, this is open source initiative. So you can go to the Amundsen data builder repository on GitHub, and you can find there on this pull request information how to use it, some sample code, and even some screenshots. Try it yourself and let us know if it worked for you. It maybe fit into the gap between the features and the feature discovery. Next, Mateusz will tell you about our plugin for MLGen, Kedro Kubeflow.
In this section, I would like to focus on two technologies, one for developing ML projects and one for actually running them, and the bridge we've built within the company to connect the two of those. So what Kedro is? Kedro is ML project framework. If you ask any Java developer what's the structure of Java code, either if it's Maven or Spring Boot or something similar, it's pretty easy to point where the tests are, how to structure their source code, and so on. In terms of ML projects, it's not always easy. And this is one of the biggest benefits that we get from using Kedro. So the project is structured the similar way, and especially in environment where you have multiple data scientists and work on multiple projects, such unification can save you a lot of hassle when working on machine learning. Another thing is customizable starters. So you can easily set, for example, configuration that suits your environment, or utilize the common libraries that you've chosen. And this can be easily reusable for other projects. You just pick the proper starter and you are good to go, just focusing on implementing the meat of the machine learning process. Another nice thing is per environment config. It allows you to define the environment configuration as well as data configuration in the config files, and you can easily switch your runtime from local development data, some test data, for example, or the production environment without changing a line in your code. This is very convenient for productizing the project. And as I mentioned, the data abstraction. Kedro uses something which is called data catalog, which builds the abstraction layer on where the data actually lies. From the code perspective, it doesn't matter if it's a SQL database, some fancy cloud technology like BigQuery, or it's a local file. The same code is used for learning, rest stays in config. So combining with environment configuration, you can easily use, for example, local files just to develop code to make sure it works as expected, and then move the same project to production and run it against your original data source. And okay, so the project is a recipe for how to train your model. What do we need else? We actually need a production pipeline to run it. You need something that's reliable, that is robust, and that you can like leave it alone and have all the automation that will take care of the process. And this for us is Kubeflow. To be specific, Kubeflow pipelines. What it does, it allows for scheduling and orchestration of workflows. So you can say it's like a Jenkins for machine learning. It does it with the containerized environment. So each step is a separate pod on a Kubernetes cluster, which is pretty convenient if you want to use different types of libraries. Environment is encapsulated, and there is like no conflicts. You can just do a lot of test a lot of scenarios, test a lot of tools, and all can work in the same cluster without interfering with each other. It's pretty flexible runtime because each step is running in a separate pod. There's no problem with plugging GPU to one of them or use extra memory settings just to give your pipeline a boost. So this is like the automation tool. Additionally, it provides monitoring and metadata collection, so we can check the status of the jobs. We can check what were the results. We can download the other artifacts like models. We can browse the metadata. So it's like everything we need to automate the models. Okay, so now on one hand we have a Kedro project, and on the other hand we have a Kubeflow, which uses its own DSL to define pipelines. How do we marry one with another? We tackled that challenge in GetInData, and the result was a Kedro Kubeflow plugin. It's a simple plugin that allows translation of Kedro pipelines to Kubeflow pipelines. And with the use of the API, it also enables to interact with Kubeflow cluster. So to run the jobs, upload the jobs, specify their parameters, specify their schedule. This automation is really good from the perspective of building a CI process around your model. So, for example, situation when on a push to the branch with your experiment, such code can be run. You can see the results of an experiment, and if you're happy with that, you merge to master, and you have the pipeline run with a production schedule. So those are the main features that plugin provides. Additionally, we support authentication. Currently, it's identity-aware proxy and Google Cloud credentials, because for development we use AI platform pipelines. And it supports Kedro Mlflow plugin. There are some extra steps to ensure that the results of the experiment are properly logged. If you are interested in the plugin, what it does, how to use it, please visit the documentation page, Kedro Kubeflow read the docs.io. And if you are looking for the code base, or you are interested in potential contributions, have a look on the GitHub page, github.com, GetInData, Kedro Kubeflow. Okay, so to sum it up, Mariusz told you briefly what is our understanding of MLOps, and he divided it to 4 areas: exploration, training, serving, and monitoring. There are many flavors in each of those areas, so you need to pick wise. And we focused on 2 technical aspects of building that platforms. So it was feature discovery, so marrying FIS with Amundsen to have a UI where you can search for the features for easier reuse, and integration between Kedro and Kubeflow in a form of Kedro Kubeflow plugin. Okay. Thank you for the attention.